this brings us to L'Hopital's rule. And I've always really liked this rule. I guess it's the math dork in me. But L'Hopital's rule says, hey, if you are having trouble, you keep getting an indeterminate form, try using L'Hopital's rule that says, hey, instead of just taking the limit of the numerator and the limit of the denominator, find the derivative of the numerator and denominator, then find the limit of both of those, which feels like cheating, but it's like the best kind of cheating that there is. And the great news is we can apply L'Hopital's rule more than once if we need to. So let's take a look. Again, now we're going to be finding the limit of the derivatives. And again, before we do an example together, it's important to point out that even though the original function that I'm showing you is using a typical normal limit, a two-sided limit, if I have a one-sided limit, whereas I'm approaching from the right or to the left, it's still the same rule that says take the derivative of each, then find the limit. So let's go back to this example. And remember, this example, we tried a couple of algebraic techniques and failed miserably because we still had indeterminate forms. And then we said, okay, well, let's look at the graph, and we determined from the graph that this limit was in fact 2. But we said how awful it was to have to graph it and then look at the graph to figure out what the limit was. So now let's use L'Hopital's rule. I'm going to take the limit of the derivative of the numerator and the derivative of the denominator and see if that helps me. Well, the derivative of the numerator is using those techniques that we've learned this week, and the derivative of e to the 2x, dx of e to the 2x, remember, would be e to the 2x times the derivative of 2x, which is 2, and then of course the derivative of minus 1 is 0, so that's where I got my numerator. My denominator is the derivative of x, which of course is 1. So now can I plug in 0 directly? Yes, I sure can. I get, and of course I could have added that in, 2e to the 2 times 0, which is 2e to the first, I'm sorry, e to the 0. E to the 0 is 1, so that's where I get the 2. So algebraically now I'm able to come up with the correct solution, even though originally it didn't work out. So we love L'Hopital. So here's another example to look at. And again, if you'll notice, I have a transcendental function and an algebraic function, and if I try to do direct substitution, I end up with an indeterminate form of infinity over infinity, and that doesn't work. So instead, what am I going to do? I'm going to try L'Hopital's rule. If I take the derivative of the natural log of x, that derivative is 1 over x. Maybe I should make my x look like an x. The derivative of x is 1, so really I have 1 over x divided by 1, which is just 1 over x. Now can I plug in infinity? Well, now I have 1 over an increasingly large number, which means my quotient is going to approach 0. So let's take a look at another indeterminate form. We have the limit as x approaches infinity of e to the negative x times the square root of x. And keep in mind that I could think of that instead as the limit as x approaches infinity of radical x over e to the x. So if you'll notice here, I plugged it in as is. But again, if I tried to plug in infinity, radical x would be the square root of an increasingly large number, which is an increasingly large number. And then the denominator would be e to an increasingly large number, which would just get bigger and bigger and bigger, so that's indeterminate. If I did it e to the negative x, well then e, that function, hopefully we know, doesn't go below 0. It approaches 0. So that's why it looks a little bit different. I have 0 times infinity. But let's take a look at what would happen using L'Hopital's rule. L'Hopital's rule says, let's keep it using the rewrite as I did here. Now I'm going to take the derivative of the numerator. So again, I'm thinking of this as x to the 1/2, which gives me 1/2 x to the negative 1/2, which is essentially 1 over 2 radical x. And the derivative of e to the x is e to the x. I took this mess, because it was a fraction and then a fraction, and rewrote it like this. Then I said, okay, well, what will happen now if I plug infinity in? So I'm going to get 2 times a very large number times another very large number. I'm sorry, 1 over 2 times a very large number. So it's essentially 1 over infinity. Well, what happens when I take 1 divided by an increasingly large number? I get 0. So here's a great question for you to try. Notice I'm asking you to solve one question 2 different ways. So the first way, I want you to solve it using a method that we already know. So it says chapters 1 through 3. That just means we're finding the limit, which we learned in chapters 1 through 3. How would I do it before I got to chapter 5? And then I want you to use L'Hopital's rule, and I want you to verify that your 2 results are the same. So I want you to do both of those. Press pause, do them both, then press play to see how you did. So for the way that I would normally do this, if I didn't know L'Hopital's rule, and probably even if I did, I would still do it the same way. I would say, well, my numerator can stay, still the limit as x approaches 4, because direct substitution obviously is the first thing I would check, and that doesn't work because I get 16 minus 16, or 0 as the denominator. But this one's pretty straightforward. My numerator is 3 times the quantity of x minus 4, and my denominator, if I factor, is x plus 4, x minus 4, because it's a difference of squares pattern. So really, I'm finding the limit as x approaches 4 of 3 over x plus 4. Direct substitution says that's 4 plus 4, or 3/8. So that's the way that I would just do it if they asked me to solve this question. What they want me to do now is verify that I'm going to get 3/8 if I use L'Hopital's rule. So all of this is what I already did. Now I'm going to use L'Hopital's rule. L'Hopital's rule says take the derivative of the numerator and the derivative of the denominator. So that's what I'm going to do. D dx of the numerator and denominator. Notice this one I went ahead and multiplied this out, but you wouldn't have to. You could say this is 3 times the derivative of x minus 4, which is 1. Either way, you're going to get 3 in the numerator. My denominator would be the derivative of x squared minus 16, which is 2x. Now I can use direct substitution, 3 over 2 times 4, which is 3/8. And notice 3/8 I get either way. So here are 2 questions for you to try. And again, notice I've asked you to evaluate using whatever means necessary, which means you can use L'Hopital, you can use one of the other techniques that we learned back in chapters 1 through 3. Whatever means necessary, like you'll have to do on a final, for instance, would be what you would use here. So try both questions. When you're done, press play to see how you did. So again, for the first one, just using direct substitution, it's clear that I'm going to end up with infinity over infinity. And that's no good. So the method that I'm going to use is not L'Hopital's rule in this case. I'm going to divide everything by x. And keep in mind that if I do that inside the radical, I'm really dividing by x squared. So x divided by x gives me 1. X squared divided by x squared gives me 1. 1 divided by x squared gives me 1 over x squared. And now I'm going to apply the limit as x approaches infinity. X approaches infinity, I would get 1 over 1 plus 0, which is 1 over 1, which is 1. So that's the method that I used. If you used another method, that's just fine too. You should still end up with 1 as the limit, because that is the correct solution. For my second one, again, L'Hopital's rule is the way that I went. E to the 2x, the derivative of that is the derivative of x squared, e to the x squared. The derivative of that is 2x multiplied by e to the x squared. And then, of course, my denominator, the derivative is negative 3x squared. Then I'm going to do some algebra. So reduce your x here. And this turns into just x to the first. And then notice if I try direct substitution here, I'm still stuck because I still end up with an indeterminate form. So now I'm going to apply L'Hopital's yet again and say, what's the what's the derivative of 2e to the x squared? And that would be 4x e to the x squared. The derivative of negative 3x is negative 3. Well, now that I don't have that x as my denominator anymore, now I can just plug it in, and I end up with negative infinity. There is a great 5.5 to 5.6 practice in your notebook. Feel free to work on that either individually or with your classmates. I strongly encourage that you do so. If you do, let me know that you've done it in Teams, and I will look at it and leave you feedback.